Hi there and welcome to this demo video where we'll be looking at the features on the left here, as you can see, of a Casio scientific calculator. Okay, so what are we going to be looking at? Well, we'll do a number of demonstrations here. Initially, I'd like us to take a look at this button here, exponentiation, in other words, raising numbers to a certain power of 10. Okay, we will also look at the ANS button here, or the answer, and we will look at the engineering button here, which is very useful for, well, not surprisingly, engineers. Also, we'll be using this negation button here, so turn a positive number into a negative number. Okay, and in another lesson we'll be looking at the use of these brackets here to force your will upon the calculator and not allow its will to force your answer, which could be wrong, of course. Okay, and all will be revealed in the lessons. Okay. Also, we're going to be looking at this button here, so raising a number to a certain power. Okay. And also we will be looking at this button or up here, which is the x to the minus 1 button. I'm just trying to find it out. Up here. Yeah, this one. Slightly different on my calculator. Depending which model of Casio scientific calculator you have, the buttons may be in a different place, but that's okay. I'm sure you can find them. Okay, so that's the x to the minus 1 button. We'll also be looking at the del button, so you delete things from right to left. Okay, and we will also be looking at using the shift button so we can bring in the pi constants here, and also we will be looking at the percent button again, so we're going to use shift and percent, and we can find percentages of certain numbers. We have some memory that could be used here, so we've got memory plus, memory minus sitting above it there, available via the shift key. Okay, and also we shall be looking at, what else should we be looking at? Possibly the logarithmic functions, or e to the x and log n, etc. We will also be looking at the setup area, whereby you can set your calculator into either degrees or radians mode. And finally, we'll wrap up with looking at the polar rectangular conversions. Okay, so let's make a start on the first demonstration then. Okay, I'm going to make some notes occasionally over on the right here, and let's start with demonstration 1. And what I would like to do here is, how about 3 times 10 to the power minus 6 sitting over 6 times 10 to the power 2. Most of you will be able to do this without a calculator, but it could be quite a bit more involved than what we see here, in which case you will need the calculator. Now, what I'm seeing here is 3 over 6, which is 0.5 times 10 to the power, and then we've got the top power take away the bottom power. So what we should be seeing on the calculator is 0.5 times 10 to the minus 8. Okay. So let's see how we can enter this. So we're going to start off with 3 And then we're going to hit times 10 to the x button here. And of course we want minus 6 in here, so I'm going to use this minus there. And then put the 6 in. Then I'm going to hit divide button, predictably. I'll be dividing by 6 times 10 to the power 2. Okay. We hit equals, and we end up with 5 times 10 to the power minus 9. Okay. And 5 times 10 to the power minus 9 is exactly the same as what we have over here, 0.5 times 10 to the minus 8. Okay, just to give you another quick demonstration, so if you did have 0.5 times 10 to the minus 8, like so, we'll hit equals. You could hit the engineering button and you get the same thing. Okay, so the ENG button here expresses answers in terms of what engineers like: 10 to the 3, 10 to the 6, 10 to the 9, 10 to the minus 3, 10 to the minus 6, 10 to the minus 9, respectively, kilo, mega, giga, or then we could have milli, micro, nano, etc. Okay, so that's a very useful button for finalizing your answers in a nice engineering format. Okay. Now then, what we could also do is, yes, so we have 5 times 10 to the minus 9, which is over here the same thing. Okay, what if we were to then, maybe we wanted to take the square root of this, so we would then have the square root of 5 times 10 to the minus 9. We should find out that that is going to give us 70.71 times 10 to the minus times 10 to the minus 6. Okay, so if that is the case, all we then need to do is go over to the calculator. We're going to hit the square root symbol. We're going to have this on display. We then hit the square root sign, and that answer, 5 times 10 to the minus 9, is, well, it's still on the clipboard if you want to call it a clipboard. You bring it up by hitting the ans key. So that is going to take the square root of 5 times 10 to the minus 9. We hit equals, and we get 7.071 times 10 to the minus 5 here. It's not really in a format like 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. So again, hit the ENG button, and nicely we have 70.71 and a bit times 10 to the minus 6. So to engineers like you and I, that would be 70.71 micro something. Okay, so it's equivalent to 70.71 micro, and it could be anything like maybe volts or amps or something. Okay, so hopefully that's useful for you. I'm going to hit the AC button here. Accumulator clear. Basically it means just clear your screen. Now let's have a look at another demo here. What if we were to have 2 times 8 minus 1? Now we know what we're implying here. What we are implying is 2 times 7. Agree? Because the brackets must come first. So what we're trying to get here is equal to 14. Okay. So if we were to do that on the calculator, we would say, okay, so hit clear again. I'm going to have 2 times is not needed. I'll use a bracket, and we go 8 minus 1, close the bracket. So we're forcing our will on the calculator now. We're saying do the bit in the brackets first, okay, and let's see what comes up. It should be 2 times 7, Let's see what happens. 14 is correct. That's exactly what we want. However, if you did not use brackets and you decided, okay, I'm going to do another one. I'm going to write it in like this. 2 times 8 minus 1. What the calculator does, it uses the acronym BODMAS. You may have heard from school. So brackets, order, division, multiplication, addition, subtraction. Order means powers, essentially, okay? So it does brackets first, there aren't any. It does order, or powers, there aren't any. It will do division, well, there's no division. The multiplication, it does the multiplication first. So what happens is, it's going to go 2 times 8, which is 16, take away 1. This will give 15, which is obviously the wrong answer to what we intend it to be. So let's try that and see how that works. So enter it in as it is here. 2 times 8 minus 1 equals 15. And that's not the type of answer we intended, so don't do it that way. Always make sure you do your brackets. So essentially you could just do as we did before. You can lean a number against the bracket and the calculator will know that you're implying multiplication, of course. Okay, so please be wary of how you enter things onto a calculator. Okay, let's have a look at another demo then. This particular demo, we're going to have, let's see, 4 to the power 4 sitting over 4 squared. Okay, and if you do the maths, 4 by 4 by 4 by 4 is 256, and 4 squared, of course, is 16, and that division gives us 16. So how do we enter something like this on the calculator? Well, I'm going to hit clear. I want to do 4 to the power 4. So start up with a 4. I'm now going to raise that to the power of 4. So that's the button to use here, X to the little square block. Okay. So I hit that button and then I hit 4 again. And as you can see, it's displaying 4 to the power 4. I now wish to divide that by, so hit divide, 4 again, X to the block button again, 2, and that gives us the wrong answer because we need to use brackets again. Okay, bear with me. Okay, so 4 to the power 4, you could argue, maybe do it this way. Okay, so let's do a bracket, then do 4 to the power 4, and then move over by hitting the right button there, and then do it that way. I think this is a more sensible way to do it. And then hit divide, open up another bracket, and then we're going to have 4 to the power 2. Move right, go away from that power, you can see it drop, do it that way. That is definitely you forcing your will and saying, okay, do 4 to the power 4, work out what it is, put brackets around it to imply that. Divide by 4 to the power 2, again, that is in brackets, and then we do equals, and we do arrive at 16, which is correct. Okay. Another demo for you. How about this division here? 1 over 8 squared plus perhaps 6 squared. Okay. Well, analytically we're doing 8 8s are 64 and 6 6s are 36. So what we're actually looking for is 1 over 100. Which to you and I is 0.01. A Okay, and how would we then do that on calculator? So here's how we go about it then. So we're going to use this x to the minus 1 button here. Okay, let's clear the decks and begin. So we're going to have 8, of course. We square 8, so we don't have to do 8 times 8. We can just hit this x squared button here. So whatever's there on screen, it will square it. 8 squared. Then we can just go straight into a plus, and we can hit 6. We want that to be squared, so hit that button again. So what we're going to do is we're going to find out what's the answer to the bottom, the denominator here. We're going to hit equals. It gives us 100. That's the number at the bottom. And they actually want 1 over 100, so it's very useful to have this button here, x to the minus 1. So it will basically do 1 over the answer on the screen for you, okay? X to the minus 1. So we do x to the minus 1. We hit equals. It's 1 over 100. Gives you it in fractional form, which is correct. It's this bit here. And if you hit this button here, standard or decimal, it will flip between the two, as you can see, each time I hit it. So it's out of 1 over 100, 0.01. It's exactly the same thing. We usually prefer things in decimal form. And so we have that one sorted. Okay, let's clear that lot and go for number 5. Now then, what if I want this? Maybe I wanted something like 2 pi times 1 times 10 to the minus 6. Perhaps all that multiplied by 0.01 times 10 to the minus 6. Okay. You could possibly be working out the bottom line of capacitive reactance or something like that, yeah, by entering something of this nature. And I think this will come to 62.83 times 10 to the minus 15. Let's see how this works. Okay, so what I'm going to do is clear the decks, and I'm going to enter something incorrect. So rather than hit 2, which is the first on the left here, I'm going to enter 3. And then go, oops, made a mistake. Just hit the del key. And it gets rid of that 3. Okay. What we actually wanted was a 2, of course. So, yeah, I'll put the 2 in. Now I want 2 times the pi here. So to get pi, I'm going to hit shift. And it's in yellow there. So shift and that button. And then pi appears here. Use brackets liberally, so I'm going to open a bracket and type in 1 times 10 to the minus 6. So you do need the 1 here, so I'm going to hit 1 times 10 to the minus 6. Close brackets. You can then imply multiplication by just opening another bracket straight away. And then we have this 0.01 times 10 to the minus 6 to go in, 0.01 times 10 to the, and we want that minus, and that's 6, and then close that bracket, and do equals, and we end up with 6.283 times 10 to the minus 14, which looks a bit like this. It will do when I hit the engineering button here, like so. 62.83 times 10 to the minus 15 is correct. Okay, good progress. Now then, demo number 6. What if we wanted to find, say, 200, maybe 20%, okay, or 20% of 200? Well, we know that 10% of 200 is 20, so we double it, you get 20%, we arrive at 40. So how do we quickly do that? You might not have nice, easy numbers like this. It could be 200.869 when you're trying to find 15.1%, which is fine. Okay, so we're going to clear the decks. We're going to type in our first number, 200. We're then going to hit times Then we're going to hit 20, and then we're going to hit percent, and percent is down there, so we need to go for shift, answer, and the yellow one appears, of course, if you hit the shift button, obviously. And then we're going to, I think, just hit equals, okay, and we arrive at our answer, 40. Okay, you could think of many more complex examples, but just follow that process that I've just inputted onto the calculator there. Okay, demo number 7. I'm going to demonstrate the use of memory here now, okay? And ultimately, we're just going to add two numbers, 2 plus 3, obviously the answer is 5. So how are we going to do this? Well, let's clear things first of all. I'm going to enter a 2, and I would like to push that into memory. Now you can see M plus here, so straight away I just hit M plus. And then I'm going to clear everything. You'll notice an M has appeared at the top here, which means something is left in memory. Obviously, it's R2. Okay, now what I'm going to do is I'm going to pick on this 3 here, click on 3, I'm going to add that to memory, so hit M plus again, maybe then I can clear the decks. Now, you would guess that 2 went into memory, and then we added 3 to memory, so we should therefore have 5 in memory. Okay, so let's see where we can find recall. So we need to recall memory, so recall's there in yellow, so we need to use the shift function and hit recall, and we have M equals 5. Okay, so memory equals 5. That's our answer. If you wanted to add a negative number to memory or subtract from memory, you would just use shift M minus. Okay, etc. Now then, how about, obviously that was 5, we've dealt with that. Number 8, maybe if we were trying to find, for example, 20 times the natural log E, of say 10, that's equivalent to, some textbooks will use ln, and this calculator has ln, which is the same as log to base E, okay? So it would be that as an example. So then all we would therefore do, if we're trying to work this out, we would start off with 20 log n. It opens up a bracket for you. You put the 10 in, and you don't always need to close the bracket, but it's a good idea to do so. 20 log n of 10, exactly as we have here, equals 46.05, which I know to be correct from advanced work. Okay. What if we were trying to use the inverse of that, if you want to call it that, so e to the something? Okay, so 2.718 is a natural constant e. Maybe we wanted to have something like e to the minus 2, which is the same as writing 1 over e squared. So how would we therefore find out what that is? Well, clear the decks. I'm going to go for shift, which gets you the yellow function on the key. So shift, and then that one, we see e to the something pop up there. We want the something to be minus 2, and that should be sufficient. Hit equals, and we end up with 0.135. So I encourage you to have a go at all of these yourself. Okay. Now then, something really important, lots of students get wrong, is when do you use degrees and when do you use radians? Well, we need to go into setup mode to do all this, okay? So, let me just have a little think about if we had a problem like this. It's only a very minor problem. The sine of pi by 4. Now, this is critical knowledge for you. Wherever you see pi, you must have your calculator in radians mode. Okay, so because we're writing pi here, we are expecting whoever, the student or another engineer or whatever, to have the calculator in radians mode. So let's do it correctly then. So radians mode, we're going to perform this calculation. So we're going to go for shift, setup. We have number format here. So on this particular emulator, number format is number 3. So hit that. I'm sorry, it's not that one. So it's shift, setup, angle unit, silly. Yeah, of course. Number 2, angle unit. Okay. So you hit 1 for degrees, you hit 2 for radians. Gradients are something, hangover. It's only like drafting people use them, so we're not going to bother with gradients. So just think of 1 or 2. We would like to do radians here, so I'm going to hit 2. And you will notice an R appear here. So a white R in a black box tells you that you're in radians mode. So now I can solve this little problem. Sine of pi by 4. Nice one, just hit the sine. Go for pi, which is shift, that button down there. Divided by 4. Close the bracket. And it gives us root 2 over 2. And you can hit this SD thing. You can go to a decimal answer rather than root 2 over 2. And you end up with the correct answer, 0.707. Okay. And that is correct. What if I was to have the calculator in the incorrect mode here? So I'm going to find out what happens when I put it into degrees mode. Okay, so I'm going to clear the decks, shift, setup, angle is number 2. I'm then going to set it into degrees mode, so I hit 1 here, of course, so I hit 1. Okay, clear. You'll notice D has appeared now in the little box there. Okay, now let's try the sine of pi by 4. Okay, sine of pi divided by 4. Close the brackets, equals, gives me a different answer, look, 0.0137 and a bit, which is not what we want. So it's absolutely critical that if you see pi, you have your calculator in radians mode. And if you don't see pi, put it in degrees mode. Okay, so let's have a look at one where we definitely imply degrees. So how about the sine of 90 degrees? Why don't I put the calculator, well, we're already in degrees mode, so let me try that in degrees mode, which is the correct mode. We do not see pi there, so we have it in degrees mode. Degrees mode, we're going to do the sine of 90. I'm already in degrees mode, that's fine. Sine of 90, close bracket, equals, predictably, 1. Which is correct because, you know, from looking at a sine wave, it looks a bit like this, and that point there is 90 degrees. And this one here, relative amplitude, is +1. Okay, so that is definitely correct. If, however, we forgot or we had our calculator in radians mode, so we can clear that, we can go for shift, set up angle, which is 2. Going to put it into radians mode, which is 2 again. Clear. And then I'm going to type in the sine of 90. The calculator will now think you want to do the sine of 90 radians, which you do not want to do. So the sine of 90, just type it in the way the other one was typed. And this is going to give you, well, something different. Okay, so radians mode is the incorrect mode. It gives us 0.89 and a bit, which is wrong. Okay, it's not that at all. It's 1. What have we got over here? Okay, why don't we now wrap up with something a bit more advanced? Is it less than 10, I think? We've done 9, so 10. Make this the last one. We're going to look at polar to rectangular. Conversion. Polar to rectangular conversion. Now then, we need to conceive some sort of problem here. So maybe we could have something like this. So we have a vector, like so. Horizontal component across here is 3, maybe 3 volts perhaps. Vertical component is 4. You know that from Pythagoras, then you're going to have 3 squared plus 4 squared. Square root of all that lot gets you 5. And if we do the maths, we find out that we have 53.13 degrees here. Okay. Now then, I'll leave it for you to experiment which mode you should have your calculator in, but because I'm seeing degrees here, it's probably safe to put the calculator therefore into degrees mode. Okay, so angle unit 2, we would like 1, let's clear, that way we're safe. Okay, because you could be doing things with sine, cos, etc., in which case you will need the correct mode. But for now, we're just going to do something simple in terms of converting rectangular to polar and polar to rectangular. Okay, so what we're looking at is pol and rec. So if you have pol on your screen, you're trying to get a polar answer. So you need to input rectangular components. Okay, so what we're going to do is we want to go polar to rectangular. So the thing you're aiming to get to, you have to have that on your screen. So I want to see rectangular. So I'm going to hit shift there. So get rec. So rectangular, I need to give it polar coordinates. So what are the polar coordinates? Well, we have a 5 for the amplitude, and the angle is 53.13 degrees. So I'm going to type in 5. You need to separate this amplitude and angle with a comma. You can see a comma there in yellow. So let's go shift that one there to get that comma. And then I'm going to type in 53.13. Close. Hopefully this is going to work. Hit equals. And we can see it's giving us an answer. X equals 3. Well, yeah, I didn't use all the decimal places for the angle. I just curtailed it at 53.13, truncated if you like. So 3, well, that bit looks okay. That's fine. And there's a bit more in display here. And if you want to see more of the display, just go across here. 3.99999, which, again, because of the truncation, 3.99 is, to you and I, 4. Which is correct. So it's giving you X equals 3, Y equals 4 on the calculator screen there. Okay, which is good. Okay, so for polar to rectangular conversion, you need to give it an amplitude for a vector, which is 5 length here, and its angle, the angle it makes with the horizontal, 53.13. Okay. Now, we could approach the problem the other way around, so maybe we want to do rectangular to polar conversion. Now, in this case, we would like pol on screen, okay? POL, that's our target. We want a polar answer. So, what I then do is I'm going to go for shift, get pol on screen, pol is here. So I would like a polar answer. I'm going to give you some rectangular coordinates. So you give it the x coordinate first, which is 3. Then you need to use that comma again, it's yellow, so shift there. Then I'm going to give it the 4, which is there. I'm going to close brackets and hit equals. And now it gives me this, it gives me r, which is the length of that vector, okay? And it's just an arbitrary letter r. And it gives me angle 53.13. So you can do polar to rectangular, rectangular to polar very easily. And this is all good when you're using complex numbers, perhaps, in some of your science or engineering problems. Okay, hopefully all or most of that has been useful for you. I do encourage you to practice a lot on your calculator, perhaps download the manual is always a good idea, and study it well. Okay, thanks for watching and see you in the next video.